We're good.
We're good? All right, I want to talk today about, or next, about expansions, and contractions. Expansions and contractions. And again, I think it is best to do this through an example problem. So expansions and contractions, you guys talked about them last year. So in other words would be stretch and compression maybe is the terminology you all used last year. It's the same and I'll use both interchangeably. So let me kind of do an example problem. So let's imagine we have f of x equals absolute value of x minus 2 minus 1. Bless you. All right. If somebody said, okay, there must have been a parent function I started with. What is the parent function I started with to get to this? What is the parent function I started with? Sorry, Jayala?
F of x equals absolute value of x.
Perfect. So just so that like letters don't get flated, I'll call it a of x, but it's the same thing, equals absolute value of x. So the first thing I'm going to do is graph absolute value. Everybody needs to be able to do this. Like that quickly. And draw it a little nicer than me. Okay. Any questions on drawing absolute value graph or how we knew this was the parent function, right? To remove all transformations. So now, question is, how did we go from a of x to f of x? What transformations have occurred to take us from a of x to f of x? Let's go Juan and Javier. Juan, take the first one. Tell us one. You can pick which one you want to do.
2 to the right.
2 to the right. And Juan, how did you know to go right? This says a negative sign here.
It's left.
Why does it flip? Because it's a what kind of transformation? Horizontal or vertical? Horizontal. So anytime you have a horizontal transformation, right, you do the opposite. So instead of going left 2, we're going 2 units right. I agree. And Javier, what's the other one?
Going down 1.
1 unit down. Perfect. Okay, so I'm going 2 units right, 1 unit down. So here we go. Let's go 2 units right. So 1, 2, and 1 unit down. Here we are. Boom. And this point is 2 comma 1. Oh no, this point is not 2 comma 1.
2 comma negative 1.
2 comma negative 1. Very good. 2 comma negative 1. Daniel.
Are you able to like have the graph like on its side?
So like this point being like here and going like that.
Yeah.
How could I make that happen? That would be y equals negative, so I want the flip, absolute value of x minus 3 plus 6. So graph this later on, don't do it right now. If you want to see something like that, it should be, let's see how good I am. And I actually want this to multiply by the whole thing. If you graph this, you should be able to get that. We'll do it at the end of class. We'll see if I'm right. I should be right. Let's see. Okay, here we go. So what I could also do, folks, is I could pick a couple other points on the orange graph, just so I know where they are. So if I assume that there is a point on the brown graph, do it in brown. If there's a point on the brown graph called 1 comma 1, right? There is a point on the brown graph 1 comma 1. Remember, brown graph is just original absolute value. What point would be on the orange graph? If 1 comma 1 is on the brown graph, how do I change that point to something on the orange graph? We did this yesterday when I gave you the table of points and I said, tell us a new point. How did I go from 0, 0 to 2, negative 1? Let's start with that question. How did I go from 0, 0 to 2, negative 1? Michelle? Right. Keep going. Hold on. So no, hold on. To go from 0, 0 to 2, negative 1, I went right 2 and down 1. So to go from 1, 1 to a point on the orange graph, I need to go right 2 and down 1. So it should be 3, 0. Folks have got to be able to do this. If you cannot transform the points, we're going to be in trouble. There's another point on the brown graph that is 2, 2. On the brown graph, I have a point 2, 2. What will that point be on the orange graph? If on the brown graph I have 2, 2, what's the new x coordinate, Matthew? The new x, just x. The new x coordinate is 4. Matthew, how'd you get that?
You got 2.
How'd you know to add 2?
Because when the 2x minus 2 is actually x plus, x 2 to the right.
2 to the right. So we added 2. So now what's the new y coordinate going to be? Cassandra? How'd you know that?
Because since it says minus 1, so since the point is 2, 2, you subtract 2 minus 1.
Good. So here we go. So that means over here there's a point 4, 1. Okay? And so I could do this for every point. I won't do it for the sake of time. Now, imagine, so any questions on getting these two? Here we go. Let's push forward. What if we said this? There's a function g of x, which is equal to 4 times f of x. 4 times f of x. Step 1. Question number 1 is, how can I rewrite g of x so this f of x is not here? How can I rewrite g of x so this f of x is not here? Daisy. Okay, so what am I going to get? G of x equals what, Daisy?
4, and that's the value of x minus 2
Yep.
minus 1.
Yep. The only thing here is we'd want some brackets here to tell us that we're multiplying the whole f of x by 4. Other than that, we're great. So Daisy just said f of x is this. Let's just plug that in. And we know we're multiplying the whole thing by 4. Keep the 4 outside. So now, this 4, and here's the new part basically. How many people think that the 4 represents a horizontal transformation? And how many people think it represents a vertical transformation? Horizontal transformation with the 4. Vertical transformation with the 4. Have no idea.
No.
Carlos, why did you not vote? Right, but is it vertically or horizontally? It's getting fatter? Is it?
Skinnier.
It's getting skinnier.
So, did Kurth never specify whether it's vertical or horizontal expansion?
Yeah.
No?
He didn't use that.
Ah, okay. So this is a vertical expansion. Or if you want to call it a vertical stretch, that's fine too. S-T-R-E-T-C-H. Stretch. And the reason we know it's vertical is because it is outside the argument. It is outside the f of x. This was vertical. It was outside the square root. This was horizontal. It's inside the square root. Anything that is happening outside the argument is vertical. Matthew
So
Resendez.
can it work if like you put absolute value for x minus 2?
That would be a horizontal change because that's inside the action. Does that make sense, Matthew? So let's do this. Is it a vertical expansion or stretch? If it is a vertical anything, does it affect y or x? Vertical transformations affect the y coordinate or the x coordinate? What happened here? Did this vertical transformation affect y or x? Come on, folks. Come on. Come on. Vertical transformations, shifting down 1 unit, having the negative outside, they affect the y coordinate because the y coordinate or the y axis is up and down.
I'm gonna stop.
Okay, you can stop and restart. So this is a vertical expansion.